This is a video about a concept called average atomic mass. Here are some other synonyms you can use for it: atomic mass, atomic weight, relative atomic mass. And I like to abbreviate average atomic mass as AAM. Okay, so what is average atomic mass? Well, if we look at the periodic table, and here's an element I pulled from the periodic table, we know that there is a top proton number, the symbol, and then underneath is this number right here. And so the question is, what is that number down here? And that is your average atomic mass, right? So the question is, how do I calculate for that number? How do I get an average atomic mass of carbon or any of the elements I see on the periodic table? Okay, in particular, carbon has many isotopes. Two isotopes of carbon that are stable, right, don't break down and decompose very fast, are carbon-12 and carbon-13. As we learned in our last video, isotopes are atoms of the same element that have just different number of neutrons in their nucleus. So we know that all of the elements on the periodic table have a bunch of different types of atoms of themselves on this planet, right, on Earth. And so when you find carbon on our Earth, you could find possibly this isotope or this isotope, all right? Well, so what does 12 versus 13 say? 12 is a lighter isotope, has less neutrons. Carbon is a heavier isotope, has 13 neutrons. 13 mass. So 12 mass, 13 mass. Remember, that's the mass number, that's the mass number. So more neutrons in the nucleus, less. That is not the neutron number. Okay, so now when scientists were deciding what to report on the periodic table, which one did they pick? And that's the thing. They didn't just pick. They didn't say, I like this one better, so let's put that one, right? They didn't do that. And honestly, you probably could tell that because there's a decimal in the number. So this is an actual calculation. And what they looked at was two things. So not only do they have to know the mass of every isotope, they also took a look at how abundant each isotope is on this planet. And abundancy is just another word for how prevalent, how popular the isotopes are. And so we can find that abundancy as a percentage, right? And normally that's given to you. So if we look here, here's some information we know about carbon. Is that it turns out that carbon-12 is extremely popular on the planet. 98.89% of the samples you'll find of carbon, right, on this planet are carbon-12. And then only 1.110% is carbon-13. So that's not a very popular isotope, right? And so if we were looking at a sample of carbon, it would kind of look like this, right? Tons of carbon-12s, carbon-12, carbon-12, carbon-12. And only a few of those carbon-13s, hence representing something like this, okay? Another good thing to note is that your percentages for your sample should add up to 100. So this percent and that percent add up to a whole, which is 100. So if at any point you're given a problem and they don't tell you a percentage, but you have the other, you can always subtract 98.89 from 100 to get the remainder. Same thing with this top. If they tell you this percentage, you could subtract this from 100 to get the remainder of the percentage. That's really important. Make sure you write that down, okay? All right, so now that I have this information about carbon, the question is then, how do I use this information, my mass number and my percentage of one isotope, my mass number and my percentage of my other isotope, to calculate what's called the average atomic mass, right? Which again was the purpose of that. How do I get that number on the bottom? Well, it's actually a special type of average. And now you hear the word average and you might be thinking math class. And actually, it's different. So this average is not like the average you do in math class. Instead, in this average, what we're going to be doing is we're going to be taking what's called a weighted average. Okay, so again, this is a weighted average. This atomic mass is a weighted average of all the isotopes. It's a special average. And so this weighted average is taking the mass of each isotope and it's weighted by its abundancy. And that's just kind of a fancy way of saying, take your isotope's mass and multiply it by its abundancy, and then take the next isotope's mass and multiply it by its abundancy and add them together. So you're gonna see me do that right now on this problem. Okay, so here we are. All I did was I took our carbon example and I wrote it up in a problem, okay? And so carbon 12 and carbon 13 are two isotopes of carbon. Their percent abundancies are these, we just said that, respectively. So really quickly, let's just cover what respectively means. That just means that you were given two values and they belong to the two carbons here in the order in which they were given. So this 98.89 came first, and so it goes to this first carbon. This one came second, it goes to that carbon. Okay. Also, something to note is that in this problem, not only did they tell us the mass number, but also you can be given the mass number like this. And so this is more of an experimental mass number that just has more significant figures in it. So obviously this would be more valuable to use in a calculation. Except if you're not given that, then at least you have that mass number with less sig figs. So again, here is my counted mass number, and then here it is experimentally determined with more sig figs. And notice the unit at the end, atomic mass unit. Atomic mass unit. That is the mass unit for this value. Okay, so now that we have all this information, we're gonna calculate your average atomic mass. So let's do that calculation. All I have to do is take each isotope. So we'll take this first isotope, isotope carbon 12, and multiply. So let's do this. Multiply my mass number. So if you remember, my mass number was 12.000 AMU. That's the more accurate one. So 12.000 AMU, don't forget the unit, times, right, our percent abundance. But remember, when you do calculations, you can't use percentages in calculations. You have to turn them into decimals. So let's be sure to divide by 100 and get a decimal for my percentages. So when I divide 98.89% by 100, I get 0.9889. And remember, by dividing by the 100, I lose the percentage and turn it into a decimal. So notice no percent sign after. So now here is my isotope of carbon 12. I'm going to add it to my second isotope. So my second isotope, so maybe we'll call this isotope 1 and isotope 2, or isotope A and isotope B, it doesn't matter, which was carbon 13. And if you remember carbon 13's information, here's my more experimentally, right, better atomic mass unit. So I'll use that, okay? That's the atomic mass unit, so that's the mass. So 13.004 AMU, don't forget the unit, right, times, and that one's percentage is 1.110 divided by 100. Be careful, right? You get 0.0111. Remember, there's no unit on that because when a percent turns into a decimal, you drop the percent sign. And so now all I have to do is take out my handy dandy calculator. Hopefully yours is a little bit up to date, more up to date than mine, but definitely not as cool as mine. And do your calculation. So that's 12 times 0.9889 equals, and I've got this long number. Depending on your calculator, you might be able to do some quick parentheses to help you, but I got for this one here 11.8668 plus, and then remember our unit, AMU, plus, and then I go ahead and calculate that other side, and I get 0.144337774. I don't know, give it enough sig figs. So we're not actually doing exact sig figs here. And then I'm going to add these two together. And when I add them together in my calculator, I get 12.01113. Now, let's take a look back at what carbon was on the periodic table. On the periodic table, I was given 12.01 as the answer for its average atomic mass. And now look at our answer. So what we'll do for our class is we will always round our final answer, that's its final, to the hundredths place. In other words, 2 places after the decimal. So my final answer then is 12.01 AMU. Circle that as my final answer, and look at that. Quite a good match. And sometimes you might calculate it and realize, well, I didn't come out exactly the same. But remember, these numbers are experimental numbers. And depending on how many sig figs you have is how closer you can get to the real answer on the periodic table. So again, we're going to be using our periodic table, which is found in the reference folder on Canvas, so that you match up a little better. And it always has 2 places after the decimal. Okay, so the great thing about this is our concept today basically represents, right, how we calculate for the average of all the isotopes. And that is, we always take into consideration the fact that the abundances are different. So this is what we mean when we say our special average. So careful not to use your math average. All right, that's the end of the video.